These are the notes for 5.7-8 using coordinate proofs for Honors Math 2. What we have today, we have this much, and then the rest are examples. So let's go ahead and get to right about here, and let's have the substitute teacher press enter now. Coming back to you by pressing the enter button again, I hope. You're now at this point, we want you to make sure that you get the midpoint and the distance and the other slope formula. If you don't have them in your notes already, please put these in there. Go ahead and press the enter now button to pause and enter again to press play. And so that brings us back to the 5.7-8 using coordinate proof notes. Let's read what you wrote down and make sure it makes sense to you. What we're going to do is we're going to start dealing with some proofs, and instead of us doing proof with numbers, which you are comfortable with, we're going to now introduce these things. We're going to do these proofs with variables. You've used them before. You just have not proved anything with the variables. This is where it gets abstract. This is where you have to follow the same process you did with numbers with letters. So don't let it freak you out that now we're dealing with terms of a B, C, and a D. You're still going to be finding midpoints, distances, and slopes with the variables the same way you did with the numbers, just so you know. Keep in mind, the reason why we're doing it is because it then applies to anything in the coordinate plane. It will work for all, let's say, parallelograms, or all quadrilaterals, or all rectangles, or rhombuses, or squares, and stuff like that. We can only use the variables that are given. Do not add your own variables, but you can use the number 0 if applicable. You will see that, especially if you're talking about an x-intercept or a y-intercept. And I gave you some hints as to where the zeros go when you have an x-intercept or a y-intercept. Horizontal distances are listed first, vertical distances are listed second, so don't just really go off of the variables. You'll see. Yeah, that's what you have to do when you put this. This means this is the horizontal distance, and that means that it's the vertical distance. We've used these formulas before. We're going to use them again. Let's go ahead and do some examples. I'm hoping that you already have worksheet 5.7-8. If the substitute teacher has not passed that out to you, I hope that you ask for the substitute teacher to pause and pass out that worksheet to everybody. So the examples that I have picked out for you that we're going to do together are numbers 2, number 10, I guess we're doing 17 and 18, and 22. Let's look at number 2. It says, what are the coordinates of the vertices of each figure? So we need to figure out what the coordinates of the vertices are. And we are not given any numbers. Everything's in terms of these variables. This is a rectangle centered at the origin with a base of 2b and a height of 2h. What does that mean? That means that this distance from here to here is 2b units, and it means that the height of this thing is from here to here is 2h units. So what you need to know is that if something is centered, if this is 0, 0, then it went up for a certain distance, and it went down a certain distance, and that will be the total distance of this 2h. And if that's 2h, and if it's centered, then that should tell you that you went up. This right here has to be h units, and then you went down. This has to be negative h units right there. Otherwise, you would not have a distance of 2h going up a positive h distance, going down a negative h distance. Together would be a 2h distance. Think of it like if there were numbers here. I'd be going up so many, and I'd be going down so many, and together it's a total distance of this 2h. Don't get confused by that negative. Thank you. I hope you said bless you. Thank you. I appreciate it. Going left to right is 2b units, which means that if I go to the right, this must be b units, and going to the left, that must be negative b units, because from 0 to this is negative b units. That's a distance of b, and another distance of b would make 2b. I'm hoping you know how that works. So now that we've said that, let's figure out where point D is. Point D is if I go left, negative b units, and I go up, positive 8 units, D has to be negative b h. Which also means if I were to go negative b units to the left and down h units, that tells me that G is at negative b, negative h. I can do the same thing to find E. I can go to the right b units and up h units, b h. And then for F, I can go to the right b units and down h units, which would be negative h. I think the important thing that I was trying to show you with this example is that it tells you that the base is 2b and the height is 2h, and you just have to remember that if that's the full distance, you have to remember, even though this is a negative value, it's because distance is always positive. If that's the distance, this distance is positive, but I have to know that going in the negative direction, that's really what that is. That's the negative direction, whereas this is a positive distance. I hope that makes sense to you. I'm hoping I'm not overcomplicating it. If you have questions on that, you will have time after this video to ask questions to each other about these examples. Number 10. I picked number 10 because it was a little bit tougher. I picked number 10 because it deals with a parallelogram. It has 3 points. We only need to find this one, even though this corner is not labeled. This is at 0, 0. Sometimes you might need to figure that out, 0, 0. But over here, if G is this distance right there, I want you to know that that means that this coordinate up here is at G units. And we have a little extra distance. It is not at G. That is not G for the x coordinate or for your horizontal coordinate. Well, you have to remember, if it's a parallelogram, that this distance here is going to be the same distance as it is from here to there. G is the distance from this corner over to here. So this bottom distance is G units, and that little distance is C, so they've gone this far past G units. What does that mean our x coordinate is? It means this is G plus C. Or I would accept C plus G, same thing. And then, how far up is this? This is K, because we went up K units for that corner, for that vertex. There's our coordinate. This is probably one of the only ones that are going to have this addition sign. Sometimes we're going to have these addition signs, so because this distance, we have to add the same distance that was away. Next example. Use FLEA to solve 17 through 21, and we're going to find 2 of them. We're going to find the slope of AF, and we're going to find the slope of EL. The tricky part about number 17 is that it has, you find the slope of AF, but it does not tell you what F is at. So, since this is supposed to be right here on the axis, and I go left 0, right 0, so this first coordinate must be 0. And I'm going up, let me get a hint. I went up how many units? It went up this many units, P units. I have to use other coordinates to see what their y or vertical distances are. I went up P units. So that F is at 0, comma P. I have to write that down sometimes. They did not tell me what E was at, so let's see. I went to the left, n units. This is n units. Even though it's a negative, remember, distances are always positive, so I need to think of that in terms of a positive n units. And then over here, to go to L, from here we went n plus P. And no, I'm sorry, n plus M units. So if that's n units, and that's that much further, that's going to match that, and that's n, then I bet you could figure out what E's distance is. Has to be m units long. How come? Because m plus n up there, and I take away the n. If I take away the n, then that gives me a distance of m. And I'm not going anything up for the letter E. I'm going 0 units, so it's a x-intercept. I'm going to call that m comma 0. Those two things you have to find first before you can do these two questions, because I need to know what the coordinate of E is, and I need to know what the coordinate of F is. Now that it says that, now that we have those, we can find the slope of AF pretty simple. All I have to do for the slope of AF, this is M for the slope, and then I'm going to put a subscript of A and F so I know which one I'm finding. This is the slope of AF. I'm going to do y2. This one's y2, P. Minus y1. This is y1. You could easily do this as y2 and this is y1, but once you decide which one's y2, then you have an order. You have a y2 minus y1 over x2 minus x1. P take away 0 was P. 0 take away a negative n adds the opposite. 0 plus n is n. And now I have the slope of AF. So the slope of AF is P over n. It's in terms of variables. It's a very abstract answer, but don't let that confuse you. That's what we're looking for. Now we're going to find the slope of EL. Slope of EL. We're going to use that same formula, y2 minus y1 over x2 minus x1. This one I'm going to use as y2. P. y2 minus y1 over x2 and plus m minus x1 m. Let's simplify that. P minus 0 is P. N plus m minus m. I'm taking away an m. These m's cancel out. Guess what? So my slope of AF is P over n, and my slope of EL is P over n. What does that tell us? If the two slopes are the same. The two slopes are the same. It means that they are parallel. It doesn't say that question there, but that's the idea. The idea is that you use something with variables to be able to prove beyond a shadow of doubt that these things are parallel, and it would work anywhere along the coordinate plane. Last example. This is number 22. Number 22 says, plot the points and answer the questions. A is at negative 6, 2. Negative 1, 2, 3, 4, 5, 6, up 2. A. B is at negative 3. 1, 2, 3, up 1, 2, 3, 4. There's B. 1, 2, 1. I'm sorry, 1, negative 2. 1, negative 2 is C. And D is at negative 2, negative 4. 1, 2, 3, 4. Those are our points. Let me take my tool here. Grab another one of those. Grab another one of those. And one last one. It looks, I can't quite tell, it could be a trapezoid, it could be a parallelogram, or it could be a rectangle, not sure. It tells me though, plot the points, then find the lengths of the diagonals. So what does that mean? I need to find the length, I need to find the distance of BD. If I want to know what the distance of BD is, I got to use the distance formula. The distance formula is x2 minus x1. I'm going to take this x and I'm going to subtract -3 minus a -2 squared. Then I'm going to do the same thing with the y's. y2 minus y1 squared. I want to see how long this is. Let's simplify this. This is a positive. -3 plus 2 is -1 squared is 1 squared is 1. Plus, but this is all inside a square root. 4 minus a negative is plus a positive. That's 8. 8 squared is 64. That makes this 1 plus 64 is the square root of 65. Do not ever split that, by the way. And this does not simplify. So I know what BD is. BD, the length of BD is the square root of 65. That's this diagonal. And I need to find the length of both diagonals. So now I need to find the length of AC. AC. I already have these coordinates written right there. So I'm going to just do x2 minus x1 AC squared plus y2 minus y1 minus a negative. And I always keep that in parentheses because I hate to say it, the most common mistake I see out of high school Math 2, Honors Math 2 students is they forget that you're subtracting a negative and they change the sign of these things. And plus, it's also in parentheses when you do 2 minus a negative, it turns it into a positive. And you have 2 plus 2 is 4 squared. 4 squared is 16. I guess a lot of kids forget about that negative. -6 minus 1 is -7, but it's in parentheses. -7 times a -7 is a positive 49. I can't tell you how many times that kids forget that you're squaring that negative inside. It's a negative times a negative, which is a positive. And don't forget, if you forget the parentheses on a calculator, the calculator will only give you what you plug it in as. So literally, your calculator cannot tell the difference unless you put the parentheses in there. So 49 and 16 makes 65, and that is the length of AC. Let me emphasize that one more time. Something that you should know, because this is not related to this question, but it is in some regards. If you try -7 squared without parentheses, your calculator does not know the difference. So -7 squared is, it's going to do the exponent first, then the negative sign, which makes -49. But if you do this with parentheses, and you have the -7 inside of parentheses squared, it knows now that you're doing a -7 times a -7, which makes the positive 49. When we use this distance formula, don't forget that that is inside parentheses. That's why the formula has those parentheses there. Find the length of both diagonals. We've done that. What is the most specific name and what property lets you know? When I look at this and I know that this diagonal is exactly the same length as this diagonal, there's only two real shapes, quadrilaterals, that have diagonals that are congruent. The first shape is a rectangle. There is a second shape that has congruent diagonals, and that's an isosceles trapezoid. So this is where I'm going to write, is it an isosceles? I don't even know how to spell that. There you go. That's my question. And so I have to check. The only way that I can check is I could probably check the slopes or the rise over the run. Let me check this slope. Up 2 over 1, 2, 3. I'm going to check this slope. Up 2 over 1, 2, 3. This slope is the same as that slope. It means they're parallel. Let me check the slope of AD. Down 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4. Down 6 over 4. Let me try that again. Down 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4. The slope is negative 3 over 2 on both. Is it an isosceles trapezoid? No, it must be a rectangle because its diagonals are congruent and its opposite sides are parallel. I just had to double check that it wasn't this one as well. That's where I'm going to stop your notes.